All right, guys, this little warm up here, just reviewing some of the exponent rules that we've discussed back in Algebra 1. So let's see how you did. First one was already done for us. Notice all they did, since we're multiplying, we need to add up the exponents. So 9 plus 7 turns out to be 16. Number 2 is very similar to number 1 there. All we're going to do is take these two exponents and add them up. So 2 plus 10, 2 plus 10 would give us a 12. So number 2 should be x to the 12th power. All we're doing is adding the exponents. Number 3, a little different here. This time we have some big numbers in front of the variables. Those are called coefficients. And what are we going to do with those coefficients? Multiply them. So we're going to multiply the 2 times the 10. Then we'll go ahead and add up the exponents just like we did with number 1 and number 2. All right, so 2 times 10 would give us a 20. And if I add the 5 plus 11, 5 plus 11 would give us a 16. So number 3 should be 20x to the 16th power. Number 4, now we're dividing x to the 19th divided by x to the 6th. What's the rule when you divide? What are you supposed to do with the exponents? Subtract. So if I subtract these exponents, I'm doing 19 minus 6. And what did you get when you subtracted 19 minus 6? 13. So we should end up with x to the 13th power on number 4. Now number 5 here is very similar to number 2. The only difference is we've got a negative exponent, but that's all right. We're still going to take the exponents and add them together. So a negative 5 plus 2, negative 5 plus 2 results in a what? Negative 3. However, there's also a rule that says we can't have negative exponents. So how do you fix it so that we don't have a negative exponent? What's another way I can write x to the negative 3rd? 1 over x to the positive 3. So never, 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 ever give me an exponent that's negative. And number 6 here, 7x to the 8th squared. Well, whenever we square something, we're saying to multiply that by itself. So what we're doing here is we're multiplying 7x to the 8th times another 7x to the 8th. So what do you get when you multiply 7 times 7? 49. What do we get when we multiply x to the 8th times another x to the 8th? X to the 16th power. Remember, we're adding up the exponents. Well, another way of doing this is just squaring the 7 and doing what with these two exponents here? What are we doing with the 8 with 2, guys? What's the multiply? That's how we came up with that 16 right there. Okay, let's take a look at the other half here, number 7. Notice there's a 3 in front of this parenthesis. I'm going to come back to that 3 in a minute. First thing I want to do is square what's inside the parentheses. So just like we did earlier, we're going to square the 4. If I square the 4, I get a 16. I just told you a second ago we're going to do what with these two exponents? What we're going to do with these two exponents? Okay, multiply them. 8 times 2 is 16. Now that is not our answer because there's still 3 in front of that set of parentheses. So we're going to have to multiply this by 3. And when I say multiply, we're multiplying 3 times 16. And what do you get when you multiply 3 times 16? 48. So we end up with 48 x at 16 power. Number 8, we're dividing again. I'm going to start with the coefficients. 14 divided by 2 would give us a 7. We said a second ago that we were going to subtract exponents when we are dividing. So if I subtract those exponents, 20 minus 4 turns out to be what? 16. So we end up with 7x to the 16th power. Number 9, we're dividing again, so I'm still subtracting the exponents. So 3 minus 4, if I subtract 3 minus 4, I end up with a negative 1. However, can't have negative exponents, so I told you the way we're going to fix this is by rewriting it as 1 over x. 1 over x is the equivalent of x to the negative 1. We just can't have negative exponents. Number 10. The first thing I'm going to do with number 10 is what's in the parentheses. Since they're multiplied, I need to add up these two exponents. So if I add those exponents, a negative 5 plus 12, what is a negative 5 plus 12? 7. So I end up with x to the 7 to the 3rd, and we're going to divide that by x squared here in a second. Now I'm going to do x to the 7th to the 3rd power. These two exponents I need to multiply. 7 times 3 is a 21. Now I'm dividing. X to the 21st divided by x squared. If I subtract those exponents, what do you get when you subtract 21 minus 2? 19. X to the 19th power should be our answer to number 10. Number 11 again, very similar to number 10. We're going to start right here with what's in the parentheses. Right now we're multiplying, so I'm going to add up the exponents. 5 plus 8. 5 plus 8 is a 13. We'll square that in a second. So I've got x to the 13th squared. We said we were going to multiply those two exponents, so 13 times 2 would give us a 26. Same thing at the bottom. If I multiply those two exponents together, we get 2 times 3, which is a 6. And now we're dividing, so now we can subtract those exponents, and 26 minus 6 is a 10. With x to the 10th power.
20.
Okay, making sure you're awake. You go on. And the last one, number 12, a little trickier here. This time notice that the operation we're talking about is addition. So I've got x to the 10th plus x to the 10th plus x to the 10th. And I go, what do you get when you add x to the 10th plus x to the 10th plus x to the 10th? 3x to the 10th. All we're doing is combining like terms. So 3x to the 10th power is what we get for number 12. All right, how many made 100? All right, put 100 on your paper. Make sure your name is on it, and then go ahead and pass that up. Then we need to take a look at the next one, which is fraction powers. Make sure your name is on that paper. Pass it up. Fraction power is the next one we're going to take a look at. All right, so we just take a look at some rules that we had back in Algebra 1. Now we're going to extend on this. It says here we're going to be investigating some exponents such as 1/2 and 1/3. What do they mean? What are they going to do? That's what we're going to look at today. So let's go ahead and get started. Number 1, the first thing we're going to consider is the function y equals 9 to the x power. So what I want you to do is go to your calculators for me, and let's go to y equals, and I want you to type in the function 9 to the x power. Now to get your x as the exponent, you're going to have to use your caret symbol, guys, and that caret symbol is right above your division. So when you type it in, you'll type it in as 9, caret symbol, and then the x. What I want you to do right now is not look at the graph, but look at the table. Look at your table. And I want you to tell me, what do you see next to -2? What is next to -2? What's that? 0.0. Okay. Now, what I'm going to do is I'm going to write that as a fraction. And the fraction is 1/81. I want you to do the same thing. That decimal that you're looking at is the same thing as 1/81. Look right next to -1. What do you see next to -1? Okay. And what is that as a fraction? 1/9. I want you to use the fraction. Right next to 0. What do you see next to 0? 1. Now let me stop right here, quick. Right now I'm saying that 9 to the 0 power is 1. Well, anything raised to the 0 power is equal to a 1. What do you see right next to 1? 9. In other words, 9 to the first power is a 9. What do you see next to 2? 81. In other words, 9 squared would be a 81. And what do you see next to 3? 729. In other words, 9 to the third power is 729. All right, so now that we've got our table filled out, what I want you to do is right here. We're going to look for what pattern emerges on the y side of the table. In other words, as I go down the y column, what kind of pattern do you notice? Whatever you see, I want you to write it in this little box form. What pattern do you notice in the y column? As I go down the y column, what are we doing? It's a lot easier if you look at the last couple of numbers, the 1, the 9, the 81, and the 729. To get from 1 to 9, to get from 9 to 81, to get from 81 to 729. What kind of pattern do you notice? What's that? We're multiplying the last number by 9. We're multiplying by 9. 1 times 9 is 9. 9 times 9 is 81. 81 times 9 is 729. So what we're doing here is we're multiplying by 9. We're multiplying by 9. Or, what if we were going up the table? Be the opposite, right? We would be dividing by 9. Depending on which direction we're going. If we're going down, we're multiplying by 9. If we're going up, we're dividing by 9. All right, so this is the pattern that we noticed in the table. Now what I want you to do is we're going to take a closer look. We're still using the same function, y equals 9 to the x power. But this time we're going to look at the tables at the numbers between 1 and 3. So we already know what we see next to the 1. We see a 9. But what do we see next to 1.5? Now you may have to adjust your table so that you can see that 1.5. So go ahead and adjust your table. Table set. And I want you to tell me what number do you see next to 1.5? 27? 27. What number do we see next to 2? We already said that. We said we see a 81. What number do you see next to 2.5? 243. And what do we see next to 3? 729. All right, so this is our new table. Notice instead of counting by ones like our first table here, now we're counting by 1/2. We got 1, 1/2, 1 and 1/2, 2, 2 and 1/2, 3, and so on. So, look at the table again. What pattern do we see over here on the y values? Are we still multiplying by 9? This time it's by 3. So this time we're multiplying by 3. Of course, like we did earlier, if we go up the table, it would be just the opposite. We would be dividing by 3. So if we go down, we're multiplying by 3. If we divide, or if we go up the table, we're dividing by 3. All right, so here's what we're going to do. Before beginning to compute 9.9 to the 1.5 or 9 to the 3.5 power, we're going to consider 9 to the 1/2 power. In other words, what does that 1/2 power or exponent mean? All right, so here's the deal. Complete this equation. 9 to the 1/2 power times 9 to the 1/2 power would equal what? Well, we just talked about the rules a second ago. We're multiplying. So what are we supposed to do with the exponents? Add them. What do you get when you add 1/2 plus a 1/2? 1. So 9 to the 1/2 times 9 to the 1/2 would equal 9 to the first power, or we would get an exponent of 1. So here's what we're going to do. What we're going to do is we're going to let x represent that 9 to the 1/2 power. In other words, this 9 to the 1/2 power, I'm going to let it be x. This 9 to the 1/2 power, I'm going to let it be x. Of course, it's still going to equal to that 9 right there. So we got the equation x times x is equal to 9. Or another way of saying that is x times x is the same thing as a x squared. And it's still equal to a 9. That's just another way of writing that equation. So here's what we're going to do. We're going to solve for x. So I've got x squared is equal to 9. What's the opposite of squaring something? Square root. So what we're going to do is we're going to square root the 9. And what is the square root of 9? 3. Square root of 9 is 3. So this is what 9 to the 1/2 power means. 9 to the 1/2 power means this right here, the square root of 9. Let's try some more. It'll make more sense once we see some more examples. Get your calculators. Get out of y equals. Get yourself a nice clean screen for me. And what I want you to do is type in 4 raised to the 1/2 power. Use the caret symbol again. 4 to the 1/2 power. What number do you get? 2. 25 to the 1/2 power. What is 25 to the 1/2 power? What is it? 5. 256 raised to the 0.5 power, or the same thing as 1/2. What is that? What's that? 16. Now, before I go any further, I want you to notice something, guys. Notice all we're doing to the numbers is we're taking the square root of it. The square root of 4 is 2. The square root of 25 is 5. The square root of 256 is 16. So when we're raising to the 1/2 power, all we're really doing is taking the square root of these numbers. All right, so let's keep going. 42.25 raised to the 0.5 power. What do we get? What do we get for this one right here? 6.5? 3 raised to the 0.5 power would be 1.732 something, something, something. And the last one over there, 80 raised to the 1/2 power is 8.944 something, something, something. So again, when we have anything raised to the 1/2 power, all we're doing is taking the square root of that number. So, do we really need a calculator to evaluate 100 to the 1/2 power? No, you don't need to put that in the calculator. Because really all I'm asking you is, what is the square root of 100? And what is the square root of 100? 10. Whenever we see something raised to the 1/2 power, all we're asking you to do is take the square root. So let me give you one more quick example. I already give you 36 raised to the 1/2 power. What would the answer be? 6. Why? Because all I'm asking you to do is take the square root of 36. So that's what the 1/2 power means. So we've just answered question C. What common mathematical process yields the same result as using the exponent as 1/2? We just said it's the square root. Square root. So the exponent 1/2 and square root mean the same thing. Let me give you a tricky one here. What if I gave you x to the 1/2 power? What's another way I can write that? What would be the same thing? Square root of x. They would be the same thing. All right, let's turn to the page. Take a look at the next one. A little bit different here. A little bit different. Number 2, this time we're going to consider the function y equals 8 raised to the x power. So let's go back to our y equals and change our function. Let's change that 9 to an 8. And let's fill out the table. 8 to the x power. What do we see next to the -2? Okay. Now what would that be as a fraction? As a fraction, that would be 1 over 64. Next to -1, what do we see next to -1? 1 over 8. 0, well, we said earlier, anything raised to the 0 power is a 1. 8 to the first power is 8. 8 squared would be a 64. And 8 to the third power, what is that? What do you see next to the third? 512. 512. All right, so let's take a look at the table. Just like we did with the first one, what pattern emerges on the y side of the table? As we go down the table, what are we noticing here? What are we multiplying by this time? 8. We're multiplying by 8. Of course, as we saw earlier, if I go up the table, rather than multiplying by 8, we would be dividing by 8. Dividing by 8. Now, if we look over there to the right, this time we're going to take a closer look at the numbers between 1 and 3. Notice what we have here is we're going to look at 4/3, 5/3, 7/3, and 8/3, which means you're going to have to go to your table set, second window, and adjust it so that when we go to our table, we can see the number sitting next to 4/3. I want to see what number is sitting next to 5/3, and so on and so on. So, go to your table set. Now you can actually just type in the negative, or not negative, but 1/3. So it counts on 1/3. Or you can tell it where to start at 4/3. Either way. Of course, we already know what's sitting next to 1. It should be an 8. The question is what's sitting next to 4/3. Anybody see what's sitting next to 16? Good. What do we have sitting next to 5/3? 32. Of course, we already know sitting next to that 2 is a 64. Next to 7/3 is a 128. Next to 8/3 is 256. And next to 3, we already said was 512. So again, let's take a look at the pattern here. As we go down these lines, what kind of pattern do we notice here? What are they multiplying by? 2. We're multiplying by 2. Multiplying by 2. Of course, just like earlier, if I go up rather than down, instead of multiplying, we would be dividing. Dividing by 2. All right, so here's what we're going to do with this. Before we look at 8 to the 4/3 and 10/3, we're going to consider the 8 to 1/3. What does that 1/3 power mean? Well, here we go. We've got 8 to the 1/3 times 8 to the 1/3 times 8 to the 1/3. If I use my rules of exponents say since I'm multiplying, I should be adding those exponents together. So what is 1/3 plus 1/3 plus 1/3? 1. 1/3 plus 1/3 plus 1/3 is 1. So we end up with 8 to the first power, or 1 is our exponent. So just like we did with the first one, what we're going to do is we're going to let x represent that 8 to the 1/3 power. In other words, this 8 to the 1/3 power is now an x. This 8 to the 1/3 power is now an x. And this 8 to the 1/3 power is also an x. It's still going to equal to 8. Or another way I can write that equation, x times x times x equals 8. What's another way I can write that equation? X cubed is equal to 8. So that would be an alternative way of writing the equation, simplifying. So what I need to do is I need to solve for x. Now, I saw earlier when we had x squared equals 9, all we did was take the square root, because the opposite of squaring something is square root. So what's the opposite of cubing something then? That's right, cube root. So what we're going to do is we're going to do the cube root of 8. Now, can the calculator do cube roots? Yes. Anybody know where to find cube roots in your calculator? Math. Everybody go to math. And I think it's number 4 or 4 or 5. 4. Number 4 says cube root. Then you can go ahead and type in your 8s. And what is the cube root of 8? 2. Cube root of 8 is 2. So this is what 8 to the 1/3 power means. It means the cube root of 8. All right, so let's take a look at a couple more examples so you can see here. 64 raised to the 1/3 power. Put that in your calculator, see what we get. 64 to the 1/3 power. What do you get? 4. And why do you get 4? Because that's what the cube root of 64 is. Cube root of 64 is 4. Let's do 216 raised to the 1/3 power. 216 raised to the 1/3 power is 6. Why is that? Well, that's because the cube root of 216 is 6. And 500. Cube root of 500 raised to the 1/3 power. I think we get a decimal on this one, right? What do we get? 7.937 and goes on. So again, all we're doing is taking the cube root of that number. So let's see if we can do the next one without a calculator. 125 raised to the 1/3 power, which is just asking you what is the cube root of 125. Anybody think they know the cube root of 125 without a calculator? 5. Why would it be 5? 5 times 5 times 5 would give us 125. So down there at the bottom, what common mathematical process yields the same result as using the exponent 1/3? We just said it, it's the cube root, which is this thing right here, cube root. All right, any questions? So we look specifically at 1/2 and 1/3. Later on, we'll look at some a little more difficult. We're going to keep it pretty simple today.